But with 9, there's two big portions. You have, first was the mutation, the other one was the transfer of genetic material. With mutation, more and more definitions, right? Forward versus reverse, wild type versus mutant. At the level of the DNA, remember you can have a point mutation or a frame shift. So for the point, we talked about transition or transversion. And this is where you have to know the difference between a purine and a pyrimidine. So for example, which one would be transition are how is it? It's hard to actually come up with a quick question about this. But function notwithstanding, if you don't worry about function or how long they're gonna last or whatever, everything else. So just transition versus transversion. Which one would be expected to be more common? Forget about the effects on the DNA or whether it's gonna last or not. Which ones would be expected to be more common, transitions or transversions? Transitions. Sorry? Well, for this one, remember there's 4 bases in DNA. You have A, right, C, G, and T. Draw arrows real quick. A to C, and it can go back. A to T and can go back. T to G can go back and go back and go forward. You can have these two, right? And you can have these two. We didn't leave anything else, right? So you have 2, 4, 6, 8. Let's see. 2, 4, 6, 8, 10, 12. Out of those 12, how many are transitions? How many transition arrows? Remember, transition is anything from A to T and back, right? Because these are, I was going to say transition, we're counting transitions. What are we counting? I forgot.
Transition.
So transitions would be A to T or true or false? False, right? That's a transversion. Transition is when you go from a purine to another. So A to G is a transition, back another, right? C to T and back. That's it, 4. The rest, the 8 are what? Transversions. So anyway, although again, this one, I would set it up in a different way. But the idea is, if there's nothing else to worry about, from this one you can see that transversions are much more likely to happen. But in reality, they don't, because it has a huge effect on the DNA. You have to know the difference between missense, nonsense, neutral. Also, you have to be able to, let's see. Let me go back to the genetic code and ask one question before I forget. It's written in the form of mRNA. If it was written in the form of DNA, it would be the non-template strand, true or false? If the DNA was used to write the genetic code or represent the code, that would have to be the non-template strand, true or false? It's true. Why is it true? Because the non-template is what? It's the coding. You want the coding to be the codings, the codon, right? That's why, in fact, remember, it's not in mRNA, it's in DNA first. You have to know the difference between what are the various mutagens, which one caused what, frame shift, nonsense, missense, yes?
Wasn't there some example that you said that even though it was a DNA, it was written in RNA? Or even though it was mRNA, it was written in DNA?
I don't know. I don't know what your question is. But all I'm saying is, the genetic code is typically written in mRNA, but in reality, it is DNA. So it's the DNA code that gets into mRNA first. So when it's written in DNA, and it still is, in many books, still giving us DNA, you have to know that it's the coding strand, which means it's the non-template. So the only difference, remember, triple A in RNA would be triple A in DNA. Triple C would be triple C. Triple G would be triple G. Triple T would be triple U. That's the difference. The difference between X-rays and UV light, right? X-rays break up the DNA. UV light causes the pyrimidine dimers. With So remember, we talked about transformation, transduction, and conjugation. So here again, you can divide it into, with transformation, you have two types. You have natural and artificial. This one is two types, generalized, specialized. I'm not going to go through all the details. With conjugation, it's really three types, right? Actually, more than three types. But F plus, F minus, H of R, F minus, and F prime, F minus. So, if you look at this one, right, with natural even, there were two types. You had Streptococcus pneumoniae and Haemophilus influenzae. Please be able to tell these apart. Streptococcus pneumoniae is the gram-positive coccus. This is the gram-negative route. This one binds DNA what? Non-specific. Non-specific. This one is very specific. Don't worry about which sequence it is and whatever. So these are really the two big things. With artificial, most of them are what? Not competent. So you have to make them so. How do you do that? You either heat shock them, right? You either heat shock or you electroporate. Electrical shock, if you like. Here, these are chapter 13. So the difference is what? Generalized can transfer any piece of DNA but at a low frequency. Specialized, only certain DNA but at a high frequency. So this is just a quick summary. With conjugation, remember these are gram-negative. So you can talk about the gram-positive model. With the gram-positive model, what? You have pheromones. You have no pili. You have aggregating substance. And what is the organism we talked about? That was Enterococcus. There are others, but this is the model, Enterococcus. Here is where you get 3 or 4 questions based on these crosses. You have to know, first of all, the characteristics of plasmids, right? The origin of replication is called ORI. C for chromosome. For a plasmid, it's ORI V. What are episomes? They can jump in and out of the chromosome. What is astringent versus relaxed plasmids? How many types of plasmids are there? Let's see what else. But ultimately, you're going to be asked to differentiate between these three. So just like the class actually did quite well, which one of these three transfers any plasmid DNA? Which one of these three transfer any amount of plasmid or some plasmid? All of them. That's by definition, they're going to transfer plasmid DNA. That's why they're conjugating. Which one transfer chromosomal DNA of any amount? The bottom two, right? Which one transfer chromosomal DNA and change the sex? Only the bottom one, right? Because the middle one does not change the sex. Which one creates a permanent, long-term, that will be permanent, merodiploid or merozygote? The bottom one. Which one, true or false, this one creates a temporary diploid, the middle one? True, right? Because only for a small amount of time, and then it gets to recombine. So anyway, these are the types of questions from 9. Any questions about? Now